Okay, so we encounter variables that are in log form. So in this session, we're going to look at how we interpret variables that are either in log form or in other forms. So there are some, okay, there are 1, 2, 3, 4, okay, 4 forms that we're going to discuss this afternoon. First is the linear. We know this, guys. This is the level regression. We have learned how to interpret this. So for example, you have this dependent variable y is equal to beta null plus beta 1 times x. Then how do you interpret the beta 1, the coefficient of your independent variable x? So we know that if you change x by 1, or for a 1 unit change in x, there's a corresponding beta 1 units change in y. Okay, ceteris paribus, of course, you know that. So it's very easy. Yung linear form, we almost all of our, if not all of our regression models have been following that form. Now there's another one, and it's called your, okay. So dito muna tayo, guys, sa log form. So this is also called the double log or lin log form, log form. Okay, double log form, wherein your dependent variable is in log form, and all your independent, all lahat ng independent variables nyo are in log form also. So if you have a form like that, structural form like that, ang tawag nun log form. And how do we interpret that? Okay, how do you interpret that? Sandali ha, i-install ko lang itong, I'm going to use this. So how do you interpret a log form? Okay, the way you do this is, sabi dyan sa notes nyo, okay. Dali guys, install ko lang itong ano. Okay, let me just engage this. Ang baliktad. Dali guys ha. Dali yata yung pag-ano. Okay. Apply, then okay. All right. Mali. Tama naman. Dito siya. Okay. So we have a model. Ayaw pa rin ha. Baliktad. Sorry guys. It's so difficult to write in this. But I need to write. Ibalik ko na nga lang tas para baliktad siya. Okay. I hope that's okay. What's happening? Last guys, last. Pag wala pa talaga. Forget it. Ayaw niya. Okay, so log guys. Ano ibig sabihin ng log? How do we interpret this? So log of y and then log of x. Pareho sila nakalog. So the way you interpret that is this way. For a 1%, no? Pag nakalog guys, lalagyan natin ng percent. Tapos wala nang units yun. For a 1%, for every 1%, guys note that 1% change in your x, okay, there is a corresponding beta 1% change in y. Take note guys na wala ko linalagay na units, no? Wala ko linalagay na units. I'm just saying 1% change in x. There is a corresponding beta 1% change in y. Now the question, do you recall guys kung anong tawag natin dito sa percentage change? May tawag yan sa, I'm sure you got this in echo. Do you know anyone please? What do you call this? Yung for every 1% change in a variable, there's a corresponding B% change in the other variable. There's a name for that. Okay, sige, balikan na lang natin mamaya yan, no? So, any questions about log? So if you encounter guys a regression model where your dependent variable is in log form, tapos yung independent variable in log form din, ang interpretation niyan dapat kung isang 1% change in your variable x will result into a beta 1% change in your y. Okay, is that clear?
Sir, question
Yes.
lang po. Sir, yung beta 1, do we still have to multiply it by 100%?
Hindi na. Hindi.
Okay po.
Kung ano lang yung beta 1 mismo, lalagyan mo lang ng percent, no?
Noted, sir. Thank you po.
Okay. Kunyari, ang beta 1 natin dito, for example, ang beta 1 mo, let's say 0.25. Kunyari lang ha. Let's say it's 0.25. So how do you interpret that? 0.25%. Okay? Lalagyan mo lang ng percent. Wag kang magmo-multiply ng ng 100. Okay, guys?
Noted, sir. Thank you po.
Okay. Then let's go here to lean log. Ano naman yung lean log? Linear yung dependent variable y natin, nakalog si independent variable x. So tingnan yung form guys. So, lean log, or another name for that is level log regression. Okay, so how do we interpret this? Okay, ang clue dyan guys, kung sino man yung nakalog, the way you interpret it is gagawin mo siyang percent. Okay, kaso magkakaiba dun sa interpretation naman, dun sa hindi naka-percent. Okay, take a look at this. Okay, so a 1% increase in x, bakit nilalagyan ko ng percent si x? Kasi nakalog siya, no? We expect y to increase by beta 1 over 100 units. Okay? So yun ang difference, no? Bitin natin ha. So ito y tapos si x naka-log, no? Or ln x. So how do we interpret this? Ito, lalagyan mo ng percent. Percent to. Pero si y ngayon magiging beta 1 over 100 units. Units siya, ha? Hindi percent kasi si y level naman siya. Okay? So for example, you have y is example lang, y is equal to let's say may b null ka dyan plus 2 times let's say log of y. No? Okay, so this is takes the form of linear and log. Okay, so how do we now interpret this? Andi dito yung B1 natin, 2, di ba? So ang pagkabasa natin dito, for every what? Guys, for every 1% change in X, no? There is a corresponding ano? There's a corresponding 2 over 100 units of Y. Okay? Any questions, guys?
None, sir.
So tandaan nyo guys pag linear si Y, log si X, just remember kung sino man yung nagiging log, lagi naka-percent yan. So in that case, for every 1% change in X, there's a corresponding, ang mangyayari kay Y naman, i-divide natin ng 100. Beta 1 over 100. Tapos units na, hindi percent. Units ang pagbasa kay Y kasi level yan eh. No? Okay, the third one guys is this one. Okay. Actually the fourth one na pala kasi tapos sa itong lin-lin na to. Yung lin-lin, yun ang inaano pa natin, yun ang lagi nating ina-analyze. No? How about log-lin? Log level regression. Dito sa log level regression guys, ang nakalog si Y. No? Ito, L and Y, tapos si X naka-level. Okay, so how do we interpret this? Paano natin to i-interpret? Ito class, no? For every, since X naka-level yan, hindi percent yan, di ba? So how do we read that? For every 1 unit. Unit yan kasi level yan. Kung ano man yung unit ni kung ano man yung unit ni X. For every 1 unit of X, there's a corresponding what? There's a corresponding, tingnan nyo to, no? Ito naman, i-multiply nyo si X ng 100. 100 times beta 1, then attach percent. No? Okay? Percent change in Y. Okay? So dito guys, yung sa lin log, si beta 1, which is si Y, ang pagbasa natin, ang change sa kanya is beta 1 over 100 units. Okay? Tandaan nyo guys, pag level, laging may kung ano man yung units nun. Pero pag percent, guys, pag log, tinatanggal yung units kasi it's read as percent. Okay? Unitless kasi guys, pag in-interpret natin si log, unitless yun. Walang unit. Okay? Is that clear, guys?
Yes, sir.
All right.
Yes, sir.
Quick
Yes,
review
sir.
Sige. Thank you. Thank you. So quick review lang. Pag lin-lin, unit-unit ang ano niyan, di ba? Tapos kung ano man yung beta, yun na yan. So for every 1 unit change in X, there's a corresponding beta 1 units in Y. Yun yung ano natin. Ceteris paribus lagi, no? Now, how about yung log-log natin? Ito, pag naka-log pareho, double log. Okay. For every 1% change in X, there's a corresponding beta 1% change in Y. Notice we're not doing anything in beta 1. No? Kung ano man yung value ni beta 1 na yan, yun na yun. Hindi tayo nagdi-divide ng 100, hindi tayo nagmo-multiply ng 100. Unlike here, guys, okay, sa lin log natin, okay, sino yung nakalog? Si X. Okay? So paano babasahin si X? Percentage change. Okay, paano babasahin si Y? Units yan. Kaso may adjustment. So paano natin babasahin to? Okay, Y is equal to ln X. For every 1% change in X, there is a corresponding, whatever your beta 1 is, divided by 100 units change in Y. Walang percent, no? Guys? Unless, guys, pwede nyo naman bang i-carry out muna tong division na to, no? Tapos, pwede nyo lagyan ng percent. You get me, guys? Hello?
Yes.
Get, sir, get.
Kunyari, yung beta 1 is 2. So you can read it as 2/100 units or 2% units. Pero may units pa rin, guys. Ha? May units pa rin siya. Alright, and lastly, guys, itong log lin natin, kung sino man yung log, guys, sabi natin, di ba, i-interpret natin yan as percentage, di ba? Si X dito is level lang. So, ang pagbasa natin sa kanya, for every 1 unit change in X, there's a corresponding, si Y naman, dapat ang basa natin sa kanya, percent, andyan pa rin si beta 1, pero i-adjust natin by multiplying it by 100. Okay. So, kunyari, kung 2 ito ulit, guys, kung 2 ito, ang mangyayari dyan, 100 times 2%. So, that's 200% change in your Y. Okay? Any questions? Okay, guys?
None, sir.
None, sir.
So, that's how you, magbibigay pa sana ako ng mga examples about this kaso medyo gahul na tayo sa oras, guys. I thought it's best for me to move on to yung diagnostics. And then next week, magle-lecture na ako ng special cases ng regression like logistic at saka siguro magbibigay ako ng isang simple na example ng mediation and then go to time series, yung mga special topics ng time series. Bitin na tayo sa oras ngayong term. Alright, so let's open the R file, guys. Kindly open the R file, the diagnostic. All right. So I requested you to already require or upload or install na natin yung mga packages. And then I hope you have already imported your OLK. Okay. Have you imported it, guys?
Yes, sir.
For me,
Right.
yes po.
Okay, sige. So, i-view ko lang ng konti to si OLK. So, where's OLK yan? Ay. Okay. So, yung OLK nyo, guys, kung directly in-import nyo dun sa binigay ko na file, dapat walang log out, log lab. Wala to ha. Sorry about this. Okay, let's proceed, guys. Let's continue reading our code. Okay, I'm now in code line 37. Okay, so this is, well, an application of what we learned a while ago, yung log-log model natin, which is also called double log or log linear model. Okay, baka malito kayo, guys, ha? Yung isa, log lin. Ha? Ito, log linear. Okay, baka sabihin nyo, bakit yung isang pag-linear si independent variable x tapos naka-log si log linear din tawag doon. Hindi. Log lin. Yung log linear, yung kompleto, ito yung log-log. All right. So first, let's look at this. Now sa economics, guys, meron tayong tinatawag na Cobb-Douglas production function. Let me write this kasi hindi maano siya sa R, no? Sige, buksan ko lang ulit itong natin. Okay. I'll be needing this again. Oops. Why doesn't it copy? Control C. Yan. Kita niyo ba yung Word file, guys?
No, sir.
Di pa
No.
po.
R pa din po, sir.
Okay. All right. I just copied that equation. yung andun sa R file, actually ganito yun ha. Kasi hindi pwede mag-exponent sa ano eh. Hirap mag-exponent sa... Okay. So this is output, okay, is equal to B1 times labor raised to the B2 times capital raised to the B3. Okay, that's the equation, guys. This is what we call the Cobb-Douglas production form. Production formula or production form, where you relate the output to with labor and capital. Okay, so this is your very famous function called Cobb-Douglas production form. So the output is a function of your labor and your capital. Multiplicative nga lang yung ano nila, relationship, hindi additive. Now, can we perform regression here? Can we regress few output to labor and capital? The answer is no, guys. No. Bakit? Tingnan mo si B2, hindi siya linear. Naka-exponentiate siya. Okay? So we can perform in this equation, we cannot do OLS. We cannot do ordinary least squares. We cannot do regression kasi i-violate na yung assumption ng linearity ng mga parameters natin. Okay, clear guys? Feedback please, clear?
Yes, sir.
Yes, okay, thank you. Now, so we can do something about this, no? So we can, by some transformation, pwede din natin kunin yung exponential, no? We can raise this to the E, then is equal to E to the B1 times Li is 2. Okay. Sorry, mali. Wait. That's very, very wrong, sorry. Okay. My apologies. So this is our original equation, not exponential, guys. What we can do is we can get the log. No? Pag kunin natin yung log ni QI, syempre kukunin din natin dapat yung log nitong buong term expression na to. Yan. Kunin din natin yung log niyan. B1 L sub I to the B2, exponent si B2, then capital to the B3. Okay, when we do that, guys, pwede natin i-implement yung laws of logarithm. No? So this will become log QI. If you recall in your algebra, yung log ng products is just the sum of the logs. So this becomes log ni B1, okay, plus, kasi products yan eh. Yung mga products yan, magiging addition sa log. Log of Li to the B2 plus another plus log of yung capital to the B3. Okay? Sorry hindi ano yung writing ko.
Sir?
Yes?
Hindi ba magiging B2 times log
mamaya.
Li?
Yes. Tama, Bern. Isi-simplify na natin, no? So this becomes, guys, if we simplify further, this becomes log of B1. And then kasi exponent, pag linog natin yan, pwede ibaba yan. Nagiging multiplication yan. Log L sub I plus B3 times log K sub I.
Sir, dalawa yung B1 mo, sir.
Sorry nga pala. B2 to. Yan, thank you. All right. So clear, guys? Clear? No? Clear? So this one, guys, we can replace log of B1 since B1 is supposed to be a constant, no? It's just a, kasi intercept yan eh, di ba? So pwede natin gawin na lang A yan, A. Okay, so this becomes log of Q sub I is equal to a certain constant for the intercept plus B2 log Li plus B3 log Ki. All right? You follow, guys? Follow?
Yes po.
Okay, so this
Yes,
becomes,
sir.
thank you. So this becomes, guys, ano to? Log yung dependent variable natin, yung mga independent variables natin, naka-log din. So log linear to, or double log. Log structural form to. So can we regress this now? Yes, kasi yung mga parameters, yung mga coefficients natin, hindi na siya naka-exponent shape, no? So linear na siya. So pwede na natin i-log to, guys. All right? So that's what we're going to do now. We're going to regress that si log output, i-regress natin kay log linear at saka kay log capital. Okay, so let me go back to R. Okay, so dito, guys, so what I did here was I inserted, or I appended another an object, no, na log out, okay, na nasa OLK. So yung nasa OLK, guys, nag-insert ako ng column, and then it's actually the log of the log output, no? So I'm going to call this log out. Ganun din kay log lab for log labor and log cap, para na shorten lang yung pangalan. Okay, so you know what's happening here, guys? Okay, so if you run this, magiging ganito, no? Magkakaroon ng log output, log labor, log capital. Okay? And then, what I want is just create another object, OLK1. So si OLK1, ang laman niya, yung OLK na 4 to 6 column lang. So, ang matitira lang yung log output, log labor, log capital. Matatanggal to, no? Yung first 3. Okay, I hope you understand this, guys. Clear? Kama, which means it includes all the rows, and then 4 to 6, yung columns 4 to 6 lang yung kasama. And I'm going to call it OLK1, output labor capital 1, data 1. So i-view nga natin to. If we run this, if I run this, kasama si view, okay, then I'm going to have this object, OLK1. So lahat yan, mga log na lang, no? Okay? Guys, clear so far?
Yes, sir.
All right. So, ang gagamitin natin ng object si OLK1 kasi si OLK, guys, kasama pa yung yung original na output labor capital. We're modeling only log output, log labor, and log capital. Kaya I think it's more convenient just to use OLK1. Okay, now let's first, as a good practice is always to look at the correlation of your variables. In particular, yung dependent natin at saka yung independent. Dapat may linearity sila. Otherwise, kasi kung hindi linear yung relationship nila, baka hindi dapat tayo hindi tayo OOLS, no? Dapat GLM tayo, generalized linear models, where higher orders na yung natin, yung regression, no? So this is a good code, pairs, tapos tilde. So tinitingnan natin yung correlation matrix ni log output, log labor, log capital from the data OLK1. So dito na yung ginagamit natin, guys, OLK1 na. Enter. What happens here? Sorry, hindi pa log output. Log out lang, no? Mali din itong log lab. Bago class, mali yung ko. Dapat sa OLK1 kasi log out lang, log lab, at saka log cap. Yan. Okay, so this should work now. Okay, kita nyo, guys?
Yes, sir.
Okay, so may correlation matrix sa tayo dito, no? However, guys, hindi siya, well, kita natin na na medyo linear, may correlation si log output with log labor. That's okay, that's good. Si log output with log capital, that's good. Ang problema natin si log labor at saka si log cap. They are also highly correlated. So sabi natin, magkakaproblema tayo niyan sa collinearity or multi-collinearity. No? But let's proceed. There's another way to do this. Mas maganda. I prefer doing it sa GG pairs. Okay, the GG pairs function. So kunin natin yung GG pairs ni OLK. Run natin yan. Mas maganda siya kasi automatically binibigay sa atin na yung, okay, so it's running. It's taking quite some time. Nagdaran pa siya, naka-red. Yan, okay. So again guys, if you want to have a good copy of this, pwede nyo rin i-snip to, snip or screen capture. But personally, I would go here and run it in console. Kasi dito sa console, pag nag-plot siya, pwede nating i-zoom. Tapos pwede yun ang i-save nyo or i-copy nyo. Oops, but wala. Yan. Okay? So pag zoom ko, guys. Okay. So mas adjustable to. Okay, so what can we see from here? Log output, log labor, guys, we can see that they are highly correlated. In fact, the correlation between these two variables is 0.971. Very high, very good. How about log output and log capital? 0.973. That's also very good. Ang problema nga natin, itong very high din si log labor at saka si log capital. Okay, we'll see this later kung ano mangyayari sa model natin. Okay, so let's continue. Let's go na to. Ba't ko linagay ito? Okay. So now let's do regression, guys. We're going to regress log output on our independent variables. So let's call this model 1 and LM, guys. LM log output regress on log lab and log cap. Log cap data is equal to OLK. Then we have the summary of the model 1. Enter natin. Okay. So this is the output of model 1. We see, guys, that you have the coefficients, intercepts, log lab, log capital. They're all statistically significant at 0.001. Very high yung significance sila. Okay. Residual standard error 0.268. And then multiple R squared 96%. Adjusted R squared 96%. Okay, overall goodness of fit, guys. The F-stat 645, 2 degrees of freedom and 48 degrees of freedom. Ito yung degrees of freedom ni regressor. 2 kasi dalawa yung regressors natin. Ito yung sa residuals. Bakit 48? Kasi n minus k minus 1. No? What's your n? Your n is, ilan guys yung n natin?
51.
51, okay? Ba't hindi naka-reflect dito yan? Okay. N minus k minus 1, 51 minus 2 for the regressors, minus 1 for the intercept. So that's 48, no? 48 degrees of freedom. P-value is practically 0, okay? So ang inference natin dyan, guys, we reject the null hypothesis that your B null is equal to B1 is equal to B2, right? It's equal to 0. Okay, so okay tayo, guys. Overall goodness of fit, okay. Individual coefficients are also statistically significant. Okay, interpret natin. Okay, ito. Sagutin na lang natin tong questions na to. Okay, number 1, guys. Number 1, describe the overall goodness of fit of the model. Use APA format. Wait. Okay. APA format, guys. Alam niyo yung APA, you know? Sa research nyo, guys, dapat APA format. Sa papers nyo, dapat APA format yung ginagamit. So ito, sinabi ko dito, the model output show that the log labor and log capital explain a significant amount of the variance in the value of log output. Then sasabihin natin kung ano yung F-stat, degree of freedom 1, degree of freedom 2, F value, P, Dapat to 0.000, no? Practically 0 kasi. R squared 0.96 adjusted, R squared adjusted 0.96 then. 2 decimal places. Okay, so that's the overall goodness of fit, no? Pinakita natin yung p-value niya, okay? But in layman's term, guys, sabi natin that the model is able to explain the variability of your dependent variable, which is log output. Okay, what does the coefficient of determination say about the model? 96%, guys, adjusted R squared. It means that 96% of the variability of your dependent variable log output can be explained by your model. Okay, does this look surprising? Yeah, very high. Ang taas, guys. Ang taas normally sa mga econometrics na data, hindi umaabot ng ganyan yung adjusted R squared. This is really fantastically high. Okay, which regression coefficients are statistically significant? We have answered that, guys. Both log labor and log capital. Okay, what is the regression equation? So log wage, alam natin yan, guys. Log wage is equal to, okay, 3.8876 plus 0.46833 times log labor plus 0.52128 log capital. Okay, so that's the answer to this question. Alam natin which regression are statistically significant. I didn't bother to write that. Okay, interpret the coefficients, guys. Ito yung dinidiscuss natin kanina. Si log labor, yung B1 natin, tsaka si log capital, B2, and report in APA format. So mag-practice na kayo, guys, magsulat ng ganyan, no? Okay. Note, guys, ito sinabi ko ulit, a 1% change in your IB will result to a B% change in your dependent variable, ceteris paribus. So how are these changes called? Itong percent change in Y, X, resulting to a B percentage change in in Y. Ano tawag natin doon, guys? Letter E? Anyone? May tawag dyan, guys. Yung percentage change ang tinitingnan natin. Percentage change in one variable leads to a percentage change in another variable. We call it, guys, what? E. Anyone?
Elasticity, sir.
Elasticities. Okay, guys. You're correct. Thank you. It's called elasticity. Pag pinag-uusapan natin elasticity, ang pinag-uusapan natin, percentage change in one variable which leads to a percentage change in another variable. No? Elasticity yon. So, ang interpretation yan, for every 1% increase in labor, there's a corresponding 0.468% increase in output. Okay, take note, ito yung tanong kanina, no? Do we multiply? Hindi, guys. As is lang. 0.46833, and then I just attach the percent. Kaya 0.46833% saan yan? Increase in output, and for every 1% increase in capital, there's a corresponding 0.521% increase in output. Okay, clear, guys? Clear.
Clear, sir.
Okay, that's your log, guys. That's your log. Okay, now, kunyari, sumusulat na kayo ng paper, ito na yung full, pag rini-report nila kunyari yung regression output. Ito, this is just one sample. So let me just read this quickly. A multiple linear regression was calculated to predict log output based on log labor and log capital. A significant regression equation was found with F2 and 48 degrees of freedom is equal to 645, P is equal to practically 0.000 yan. R squared is 0.96, R squared adjusted 0.96. The model's predicted log output is equal to this plus this times log labor plus log capital, where log labor and log capital are measured in $1,000. No? Log output increased 0.468% for each 1% of log labor and 0.521% for each 1% of log capital. Both log labor and log capital were significant predictors of log output. Okay, So, di ba, ang ganda ng pagkasulat, it captures all the necessary details needed. And this is based on APA, American Psychological Association. So, seventh edition na yan. Pagpunta nyo na sa Recifin, I don't know if you have a subject which you already discussed yung APA. If not yet, guys, I would suggest that you medyo magbasa-basa kayo ng konti about how to write journals, how to write research papers using APA format. Okay, so what are the advantages of using, guys, pasensya na sa pace ko You know, ano na lang, 40 minutes lang, haba-haba pa na yung discuss natin. I really don't know how to squeeze in the discussion. Pero okay lang so far, guys?
Yes, sir.
Okay lang? O kaya nga, I apologize, guys, kasi I have to do this, no? Na makikinig lang kayo for the whole 90 minutes. Dati kasi, di ba, hindi ko ginagawa to dati. Isulat nyo yung, kasi may learning dun eh. Kaso nga lang, guys, in the interest of time, tapos next, ano pa? Wala, asynchronous pa tayo. But again, guys, sabi ko nga, I'll open, asynchronous nga, pero if you want to attend my recording, okay lang, no? Okay, question number 6. Advantages ng using elasticities. Ano yung elasticities, guys? Kapag nakalog pareho yung dependent-independent variable natin, they are pure numbers, devoid of units. So hindi siya measured in dollars, person hours, capital hours, etc. because they are ratios of percentage changes. So pag in-interpret natin yan, guys, it's always in the form of percent, no? Yun ang advantage ng elasticity. Okay, true or false? The regression model is QI. Ano ba yung A natin? Ano ba yung natin, guys? Yung intercept. Ito, no? So tama ba, guys, na ang natin, sulat ko dito, Tama ba na ang regression equation natin? Pakidictate nga. Log of our output is equal to, ano yung A natin? 3.8, Pakidictate, guys.
3.88760.
876 times 0.4, ano to?
6833.
6833, no? Times capital
0.52128.
52128. Okay? Is that correct, guys? Ito ba yun? Kasi sabi natin, ito yung equation natin. Ano, guys? Now, if you wrote the equation this way, tama tong A na to. This is 3.8876. Pero dapat ang pagsulat natin, 0.46833 times log labor plus 0.5212 log capital. But we're not writing it this way. Ang gusto kong pagsulat, ganito dapat, no? So, ito tama to, guys. Tama ito. Kasi, yung B2 natin, ito di ba? Saan yan? Let me go back here.
Sir, hindi namin ulit makita, sir.
Sorry.
Parang nakahang ata yung...
Hindi ko na-share yung word ko. Okay, my apologies again. All right. Kita nyo na, guys?
Yes, sir.
All right,
Yes,
salamat.
yes, sir.
Okay, sorry. Sorry again. Okay.
It's fine, sir.
Thank you, Bern. Saan ka na? Yan. Okay. Diba? Ito yung natin, guys. Ito yung equation natin Diba? Si B2, yun din yung 0.48 something, no? Ito yun. Kasi si B2, guys, pagpunta natin dito, B2 pa rin siya. Right? Si B3, ganun din. Ito pa rin. So, okay lang siya na erase natin labor to the 0.4863 tapos capital to the 0.522. Ang problema ito. Guys, kasi si A, guys, hindi naman B1 yun Okay, you follow, guys? Yung nakuha natin na 338 point, this one. Ito, guys, this is your A. Ito yun sa equation natin. And A is not equal to B1. Bakit? Ano ba relationship ni A at saka ni B1, guys? Di ba ito? Ayun, no? A, guys, A is equal to log of B1. Okay? So if I want to get B1, anong gagawin ko? Kasi sabi ko, ano ba yung back to the original equation? If I'm going to write the original equation, it's this one, ito. Okay? I need B1, then labor to the B2, then capital to the B3. Yung B2 at saka B3, na-preserve sila. No? Hindi naman nabago yun eh. Yung pa rin, no? Ang nabago, guys, si log B1. Kasi ginawa lang natin siyang A. Sabi natin kasi si log B1, tanggalin na natin log dyan kasi constant yan eh. Okay? It's a constant. So we just replace it by a variable called A. So if you're going to, again, to write the original equation of B1 times labor to the B2, capital to the B3, we need to find B1. And B1 can be obtained by, ano? By, paano ko tatanggalin yung log dito? Guys, kunin mo yung exponential niya. So magiging e to the log B1 is equal to e to the a. Okay, then remember, exponential and log are inverse functions, kaya magka-cancel tong dalawang to. Magiging B1 na lang yan. So it become B1 is equal to e to the a. Okay? Nakikita nyo ba guys? Sorry ah. Can you see? Hindi na mahirap pag kailangan bababa. Oops. Reading ko ah. Let me rewrite this quickly. So alam natin guys na si A is not equal to B1, ha? Iba yan. No? Kasi replace lang natin si A is actually A is equal to log ni B1. Okay, based on the equation above. So how do I get B? In order to get B, kailangan natin i-exponentiate both sides. Kasi si exponent at saka si log, they are inverse functions. So pag kinuha natin exponential ni A, that will be exponential ni log B1. No? And since exponential and log are inverse functions, magiging B1 na lang to. Yun guys, yun. That's the value of your B1. Okay, so let's go back to R now. Here, share. Okay. So, gusto natin ibalik yung gusto natin malaman kung ano yung saan ako? Okay. So, true or false? Okay. So, how do I get B1 guys? B1 is X E to the dapat capital E. E to the what guys? E to the A. Ano si A? A is this one. Control C, Control V. Okay, so that's how you compute exponential e to the 3876. How much do you get, guys? Oops. Okay, mali. EXP. Kala ko nasa Excel ako. Hindi, nasa R pala ako. Okay. Kuha nyo, guys. 48.7963. Kaya ito, guys, yung sinabi ko. Okay. Where's that? Here. Okay, kaya mag-equation natin guys, okay? yung original equation, output is equal to 48.7936 times labor raised to the 0.46833 times capital raised to the 0.52128. Any questions, guys?
None, sir.
Wala. Si Bernd lang ba yung walang comment? The rest, guys?
Answer.
Wala. Kaya clear, ha? Clear. Okay. All right. So, tuloy natin yung model natin. Ang model natin, ano yung model natin, guys? Log Q. Okay. It's this one, or in terms of, or we can write it as, di ba sabi natin, log Q is equal to 3.8876. Let me go up there. Okay, 3.8876 plus 0.46833 log labor plus 0.52128 log capital plus your error term. Yun ang model natin. Or, it's the same as this one, guys. Output is equal to 48.7936 times labor to the 0.46833 times capital to the 0.52128. Okay, they are equivalent. Pareho sila. Okay, so after having generated our model, we don't stop there. Pupunta tayo sa diagnostics, guys. Kasi remember, may mga assumptions ang classical linear regression model. Ano yung mga assumptions? Okay, dapat linear yung relationship ng dependent at saka independent variables natin. Pangalawa, error terms. Dapat yung error terms hindi heteroscedastic. Dapat constant yung variance natin. Kasi error terms natin, minimeasure natin yung variance niya. So kapag constant yung variance, ang tawag doon, homoscedastic. Pag hindi constant yung variance, ang tawag heteroscedastic. So violation, guys, ng classical linear regression model kung heteroscedastic. So dapat i-remedy natin 'yon. Third, ano pang assumption natin? What's another assumption, guys? Ano pa?
Independence of errors.
Okay, independence of error terms. Okay. Dapat yung error terms natin, dapat independent sila. Dapat walang autocorrelation, guys, among the error terms, no? Okay, but it's more a function of time series, no? Ano pa? Normally distributed yung residuals. Normally distributed dapat yung residuals. Although hindi naman siya talaga ganun strict na requirement. In fact, hindi siya linilis as part of the classical linear regression model. Okay, next, ano pa? Outliers. Dapat wala mga outliers. Kung meron man, dapat hindi siya influential. So dapat wala mga influential points. Okay? Okay, guys? All right. Also, kasama din dapat yung pag-sampling. Dapat random yung pag-sampling ng observation points natin. Okay, so we go to this this function GVLMA. It comes from the GVLMA package. And then global validation of linear model assumptions. So parang ano to, parang overall test, no? So we can start with that. So here we're going to have this model, GV model 1, tawag natin GV model 1, and the function is GVLMA. Ano tong model 1 na to? Ito yung regression model natin. Nasa taas, model 1 natin yan, regression model natin. You follow, guys? Mod 1. Yan, model 1. So pinapatest natin using GVLMA method yung validation ng linear model assumptions natin. And it can also test yung skewness, kurtosis. This will be for the distribution of the error terms, and heteroscedasticity. So check natin, guys. Run. Okay. So inulit yung yung output, no? Itong code na to, uulit yung output, tapos sa ilalim merong What do you have here, guys? Global stat. Okay, assumptions of linearity not satisfied. Skewness, assumptions of linearity not satisfied. Kurtosis, not satisfied din. Yung link function, acceptable daw, pati yung heteroskedasticity example. Okay, so naglagay ako ng konting, ano dito guys, konting insights kung ano to. Galing kay Peña and Slate tong GVLMA. So ang sinasabi nila, yung assumptions natin sa linearity are normality, heteroskedasticity, linearity of the relationship, and uncorrelatedness, yung independence ng error terms natin. Okay, so si Peña and Slate ang nagsulat, no? Tapos sabi ng authors na yung uncorrelatedness ng error terms this is referred to as independence. Okay? The author also refers to other scholars who indicate this as independence of the residuals. Okay, so may konting explanation dito guys. Okay, pag global stat, overall metric yan. This states whether the model is as a whole passes or fails. So yung model natin as a whole failed, no? Kasi not satisfied. Tapos ano pa? Skewness, measuring the distribution, hindi normally distributed yung error terms natin. Tapos hindi din siya normally distributed kasi yung kurtosis, it tells us of the possible presence of outliers and influential data. Okay? So yung link naman, correctly specified ba yung model natin? Pag sinabi natin correctly specified, ang ibig sabihin nun, tama ba yung structural form? Dapat ba nakalog yung ano natin, yung mga variables natin? Or may kulang ba? May missing ba tayo na na variable? Okay. Sabi niya mukhang acceptable naman, tapos yung heteroskedasticity mukhang acceptable din. But guys, let's not put too much trust in this, yung GVLMA na yan, kasi individually, iti-test natin isa-isa. But this is just a guide, and it tells us at least an overall picture. Okay, itong number 1 guys, outliers, leverage, and influential data points. Medyo medyo mahaba-haba yung discussion dito. Hindi na natin mababasa lahat. Kaya nga guys, ni-notes ko na to. Okay? I spent time really writing this up and getting some notes, no? Para kahit na hindi ko ma-discuss in greater detail, at least andyan dyan na yung notes sa inyo. Okay? So, of course, it's important that you read this. Okay, so this code now, yung ipapartition natin, okay? Partition in 2 rows and 2 columns, yung mga residuals. Tapos ipapaplot natin. So let's run this. Okay. So nakita nyo yung output guys, 4, no? 4 na output. 4 plots, can you see it guys? Hello?
Yes, sir.
Alright, 4 plots. Unang-una, plot of yung residuals nasa y-axis versus the predicted values, yung fitted values natin. Ngayon, okay, may mga notes ako dito Ito, guys. So, pakibasan lang to, no? Pero let me just point out that importante to para ma-determine natin yung assumption ng linearity of the relationship between your dependent variable and independent variable. And also, homoskedasticity. If the model does not meet the linear model assumption, we would see our residuals to take on a defined shape. Ano ibig sabihin nun? Magkaka-pattern yan. Nasabi ko sa inyo, di ba, parang fanning out, pataas, tapos pababa yung ibang parts. Parang nagiging fan siya. Or may pattern. Pataas, kunyari, o pababa. O may polynomial, may binomial na shape, parang U-shape or inverted U. Pag ganun guys, automatic yan. Heteroskedastic yung natin, residuals natin. Kasi, ibig sabihin nun, meron pa sa data natin na hindi na-capture ng model natin. Yung, kunyari, U-shaped yung U-shaped yung residuals. O ano in-indicate nun? Yung movement na yan, hindi na-capture ng model natin. So siguro dapat nag-binomial yung natin. Dapat yung x siguro natin naka-squared. So, ibig sabihin din may specification error tayo. Kasi hindi tama yung structural form natin. Dapat siguro naka-squared yung natin, independent variable. Pero naka-x lang tayo. So, anong nangyari? hindi na-capture ng model natin yung power na yun, yung galaw ng ng quadratic or kung cubic man siya, etc. So yan ang sinasabi niyan, okay? Clear yan, guys? Dito yan, ha?
Yes, sir.
Sabi dito, ang sinabi ko dito, if your plot looks like a parabola, that's bad. No? Your scatter plot of residuals should look like the night sky. Ano night sky? May makikita ba kayo pag tumingin kayo sa night sky? May makikita ba kayong pattern doon? Wala. Of course, except yung maliliit na, yung mga Big Dipper, Small Dipper, Pegasus, etc. Yung mga shapes na sinasabi nila, ganoon daw. Pero otherwise, guys, as a whole, no? Wala. Talagang random yan. Diba? Your residual plot should look like a night sky, no distinctive patterns. Okay, sabi dito, yung red line yan, guys, yan, so your scatter plot should also be straight and horizontal. So as much as possible, ito, dapat straight yan. Okay, ito may mukhang shift ng konti, no? But generally, parang straight naman siya. So we're okay with the residuals versus fitted. Mukha naman siyang homoscedastic yung error terms natin. Okay, next. How about the normal QQ plot, yung pangalawa, guys? Anong assumption ang tinitinan dito? Yung normality ng residuals. Okay? So ideally, dapat yung mga yung mga residuals dapat nasa 45-degree line na yan. Ayan. Dapat andyan siya. Okay? Okay. Pag wala dyan, guys, usually ina-identify na ng model natin possible influential points. Okay, this could be an outlier, this could be a leverage point. Mamaya discuss ko na ang importante sa atin, okay lang naman maging outlier yung isang observation, wag lang siya maging influential. Okay? So okay lang naman maging outliers yung mga data natin, pero ang ultimate test natin, guys, is the influence points. Kasi yung influence, pag influential yung observation, ibig sabihin nun, pag tinanggal mo yan, grabe yung magiging bago yung yung model natin. Ibig sabihin, ang laki ng hatak. Ang laki ng hatak ng model na yan, ng observation point na yan. Okay, so going back here, okay. So yung sa QQ plot dapat, guys, nasa 45-degree line. Okay, so may pinakita na kagad si R sa atin dito na may red flag na dito, 27, 8, and 32. So this means mga possible influential points. Okay? Clear, guys? Clear? Dito yan, ha? Clear?
Yes, sir.
Okay, sabi dito, however, aside from the 3 data points, si 27, si 8, at saka si 32, observations lie well along the 45-degree line in the QQ plot. So, mukha namang normality, no? Pero, mga visuals pa lang to, guys, ha? Mga visuals pa lang to. We will have to statistically test for this pa. Okay, next, scale location. Ano naman yung scale location? Standardized residual siya, guys. Ibig sabihin yung mga residual, in-standardize siya. Ginawang normally distributed yung residuals. Tapos, kinuha yung square root niya, no? Versus the fitted or predicted value. So, kailan ginagamit to? Si scale location. Ganun din, guys, for homoscedasticity. Okay, dapat, yung natin, guys, yung line natin, dapat, yung mga regression, yung mga points ng regression, residuals natin, guys, dapat random, no? Wala dapat pattern, just like the night sky. Pag ganun yung plot natin, okay tayo. If your red line has a positive slope to it, may problema tayo, no? Tingnan natin. So may red line natin sa scale location. Ito, medyo dito sa dulo, dito yung problematic natin eh. And dito yata yung 32 na yan eh, no? So, medyo questionable kasi dapat as much as possible, straight line eh. But dito sa point na to, medyo bumababa siya. No? Okay, yun ang issue natin dito sa scale location ito. But then again, guys, visual plots are there only to aid us to have an initial look at your model. Magsa-statistical test pa talaga tayo. Ala. Dali 400 rows. Tapos nasa 100 pa lang tayo. Okay. Where am I? Alright, dito na tayo sa, okay. Residuals versus leverage. Dito sa residuals versus leverage, guys, pinapakita dito si Cook's distance. Yan. Si Cook's distance, ginagamit natin yan para malaman kung influence point yan. Kasi kung influence point yan, we have to address that. Kasi, ibig sabihin nun, either baka mali yung yung pag-input, maraming possibilities. So, just one of them is just baka mali talaga yung pag-input ng data niyon. So, it has to be studied. So, ano sabi ko dito? Helps us to find influential cases. Kung meron. No? Now, take note, outliers may not be influential points. Hindi common outlier siya, ibig sabihin na niya critical siya, na may influence siya, not necessarily. Kailangan i-test pa yun. Ang influential outliers are our greatest concern. Importante yan kasi they could alter the results. No? Ang laki kaya ng impact niya sa results, depending on whether they are included or excluded from the analysis. Kung wala naman tayong influential cases, okay, ano sabi dito? You will hardly see a dash red curve. Kaso sa atin meron, may red curve, oh. Ito. Okay, tas ito sa point 30, si 32, andyan dyan, yung sa red dash line na yan, nasa 0.5 niya dito. Tapos may isa pang level. Okay. Ibig sabihin, parang nadidelikado tayo dito kay 32. Pero yung 8, yung dalawa, yung 8 at saka 27, parang nawala. Iba yung nag-reflect dito, 19. Pero sa 19, medyo malayo naman sa Cook's distance. Ito na si 32, guys, ang maaaring candidate for influential. Okay? Sino mas importante, guys? Si outlier o si influential?
Influential.
Yes. Si influential, guys, ang tinitingnan, not necessarily si outlier. Pero importante pa rin si outlier kasi si outlier pwedeng maging influential. Necessarily, guys, lahat ng influential are outliers. But not all outliers are influential. Okay, so ang comment ko lang dito, guys, 32, 8, and 27 stick out. Si 32 very close to Cook's distance. Okay, pero wala dito si 8 and dito si 27. Si 8, asan si 8? Baka hindi lang makita. Okay, kaya nga guys, mas maganda kung ito gagamitin nyo, no? Kasi pareho lang to. So plot model 1, this will give us the same plot kaso mas malaki na. Yan. Okay, mas klaro ha? Guys, clear? Guys?
Yes, sir.
Pareho lang yan na nasa taas, no? May nadagdag nga lang sa 4, tingnan natin itong 4. So itong 2, okay, sigaran ko na. 2, pareho lang, normal. 3, scale location. 5, residuals versus leverage, pareho lang yan. Okay, so mas kita dito, no? Wala dito si 8. Can you see 8, guys? Si 27 andito, si 8 na wala, ano? So wala siyang kinalaman sa sa pagiging leverage, no? By the way, guys, anong kaibahan ng outlier at saka leverage? Okay, si outlier, guys, ito yung mga medyo hiwalay dun sa mga usual na data points based on the y-axis. So dito sa leverage, sa outlier, guys, ang tinitingnan natin yung kakaiba siya in terms of the y-axis. Si leverage naman, kakaiba siya in terms of the x-axis. Okay? Kaya pag sinabing, kasi di ba pag data point, guys, di ba x and y yan eh. Okay? So pwede kasi ang isang data point na medyo nahihiwalay siya in terms of the y value. No? Pag ganun guys, outlier yon. Pwede rin naman medyo nahihiwalay siya o naiiba siya o nabubukod tangi siya in terms of the x-axis. So pag ganun, that's a leverage. Okay? And again, guys, ang concern natin, not the leverage, not the outlier, but the influential data points. Okay. Ito, guys, ito. Okay. Ito yung 4. Ito yung wala dun sa taas. Okay. Yan. Cook's distance, no? Cook's distance. So, kita natin si 32, 19, and 27. Sila yung nangunguna in terms of Cook's distance. Saan ginagamit guys si Cook's distance? Ginagamit siya para malaman natin kung influential yung data point na yan. Bakit? Kung influential, anong gagawin natin? Well, may decision tayong gagawin dyan. Anong gagawin natin? Tatanggalin ba natin yan? Or i-remedy ba natin yan? Kasi yung pagtanggal ng data point na yan, that's the last thing that you should do. Kunyari, nagkamali lang pala ng pag-input ng data. So anong gagawin? Hindi mo na pwede nang balikan yung respondent. Okay, so may mga ano diyan, may mga remedies. Kunyari, pwedeng ang ilagay diyan yung value ng mean. Yung mean ng ng value na 'yon, ng variable na 'yon, or yung median niya. Okay? So those are possible remedies kung influential siya. Huli na yung and it's not advisable to remove that data, no? That data point. But in some cases, ginagawa 'yan. Okay. So mamaya i-determine natin kung influential to si 32, si 19, si 27, si 8 nawala. No? Nawala siya. So tingnan nyo guys si 8 kanina outlier siya, no? Pero hindi siya influential. So that can happen. No? It doesn't mean na common outlier siya ay masama na. Hindi. Depende yun sa influence yung tinitingnan natin diyan. Okay, this is another way guys. Mas maganda nga lang yung nito, yung printout, pareho lang yan, autoplot. Okay? So mas maganda yung yung output, mas clear kaysa dun sa nauna kanina. Okay, but they're the same. No? I'm just showing you some possible codes to generate this. Okay, ito. Ito naman guys, from the Brooms package, we call it we'll create an object called model.diagnostics.metrics. Okay, tapos ang gagamitin natin sa augment function for the model 1, linear model. Tapos yung generate natin yung head nito. Okay, run natin to. Okay, so andito yung mga variables natin. Andito yung fitted value. Andito yung standard error ng fit. Andito yung residuals natin. Yung dot hat, explain ko lang mamaya, dot sigma. Andito si Cook's distance. Ito yung importante sa atin. This will now tell us kung, well, this is just a record of the Cook's distance. Tapos may cut-off yan na ginagamit para masabi natin kung influential siya. Okay, so I just show you this para alam natin na you can, if you want a table na i-generate yung mga pertinent measures on the residuals, you can use this augment from the Brooms package. Okay. All right. So ito naman guys, pareho lang to. No? It's just the same. I'll run this. So dito, we create an object called Cook's dist. And then, ano lang niya guys, isusort niya si Cook's distance ni model 1 decreasing. Ang ibig sabihin nun, decreasing from the highest to the lowest. Para alam natin guys kung sino yung pinakamalaking Cook's distance. And then 3 decimal places. Run this. Okay. So si 32 Yan, 32, 19, 27. Sila yung mga highest pointer in terms of Cook's distance. So consistent guys sa plot, kita natin si 32, even sa listing. So ito na yung Cook's distance ni 32.447. Okay, by the way guys, there are several ways to compute yung distance. Cook's distance is just one of them. Okay, clear dito guys, clear?
Yes, sir.
Yes,
So sino
sir.
pinakamataas na Cook's distance? Si observation number 32. Pangalawa lang si 19, pangatlo si 27, no? Si 8, malayo na siya. Although kanina parang isa siya dun sa mataas. Okay, which tells us na hindi common outlier siya automatically na influential siya. Okay, so ang candidate number 1 natin diyan si 32. Okay? All right, next. Ito naman guys, galing sa yung natin sa stepwise regression, si OLS RRR. Ito importante din to, no? Kasi pinapakita dito yung bar plot at saka yung chart ng Cook's distance for model 1. Run natin to. Yung una. Okay, so tingnan nyo guys. Alright. So Cook's distance bar plot. So ito din yung threshold ito. Okay? Yung red line na yan. Kapag lumampas dyan, candidate yan for influential data point. Okay? 3 guys? Hello, clear?
Yes,
Yes,
sir.
sir.
Okay, pwede rin namang chart. Okay? Pareho lang yan. Ito, naka-chart na ito. Mas malinis nga lang, ano? Okay. Yung apat na highest pointer natin, andito si 8, pero medyo malayo siya. Talagang si 32, very consistent na, ano, na candidate for influential data point. Okay, then we also have another way, guys, hindi lang si Cook's distance ang ginagamit. Merong DF beta, merong DF fit. Also used for determining whether a certain observation, a certain data point is influential or not. So just be aware, guys, na minsan pag gagamit kayo ng ibang software, makakita kayo na may DF beta, DF fit. Ang ibig sabihin ng DF beta, difference in the betas. Yung mga betas, guys, yun yung mga coefficients natin. DF fit naman, difference in the fits, in the fitted value. Bakit difference? Kasi ganito yan, guys. Kwento ko lang, ha. So meron tayong data, di ba? Meron tayong data. Renegress natin. So may model tayo. May mga predicted value tayo, di ba? Correct, guys? Hello? Hello? Nag-regress tayo, guys. Nag-regress tayo. Tapos, based on that, meron tayong predicted values. Si y hat. Right, guys?
Yes, sir.
Tapos, kunyari yung isa, by way of computing yung Cook's distance, nakita natin na possible na influential data point yan. So, ang ginagawa, tatanggalin siya. I-remove yung observation na yun. Tapos, magre-regression ulit. Tapos, i-compare ngayon yung predicted value na kompleto yung data minus yung predicted value na wala yung data point na yun. Yung kinukuha yung difference nila. Ang tawag doon, difference in the fitted value. Tapos, isasum lang yun, tapos i-divide na a certain factor para makuha tong DF fits. Okay? Ganun din si DF beta. Ang kino-compare naman, guys, yung mga betas natin, yung mga coefficients. Alright, so let's look at this. Run natin si DF beta. Okay. So ito, guys. So sa bawat independent variable, sinama pa nga si intercept din. So si log lab labor, okay, tingnan natin. May mga candidates siya na influential points. Si 27, si 31 ba to? 19. Talagang lumalabas yung tatlong to. Si 32 talaga yung pinaka-highest pointer, no? Tapos ganoon din si log cap, guys. Kay log cap ang pinaka si 19 eh. Asan si 32? I think this is 32. Okay, so bawat variable, guys, meron yang DF beta. Okay. All right. So ito, guys, pinapakita lang dito sa atin yung mga possible na na candidate for influential. So ito, guys, pakibasa na lang yung DF beta. Ayan, difference in each parameters beta. Kasi kino-compare natin, guys, kung full model ando dun lahat versus yung tinanggal natin na one at a time yun, yung tinanggal natin na pinakamataas na influential points. Okay. All right. Merong test na pwede natin malaman kung significant yung outlier. Okay? Ito. We can also use the outlier test to detect outliers. Pero outlier pa lang to, guys. Itong function na to makes use of Bonferroni adjusted outlier test. Ang null hypothesis is that the observation is not an outlier. Okay, so ito, guys, yung test natin. Yung dapat null test. Dapat mali ito. There are no, mali yung statement ko. Sorry. There are no outliers. Okay. So run natin. Okay. Okay. So based on Bonferroni, guys, ano sabi natin dito? P-value is practically 0. So ano to, reject or not reject?
Reject, sir.
Reject the null hypothesis na walang outlier. May presence ng outliers. Okay? Yun lang sinasabi nitong Bonferroni test na to. And then, itong QQ plot, pwede din natin i-run to. Okay? Similar lang to sa kanina, no? Ito yung QQ plot natin. So dito pinapakita na, dito outlier si, yan talaga, si 32 at saka si 8. Ito yung QQ plot natin kanina, guys. And then, tingnan naman natin yung leverage points. Okay. Ito yung parang pareho sa residual leverage points. So sino yung medyo sino yung mga may leverage? So, yan, no? Consistent sila eh. Sa log lab at saka sa log cap. Okay? So I hope clear sa inyo guys yung discussion ng outliers, leverage, influential. Bottom line, pinaka-importante guys yung influential point. Kasi the addition of that really affects your predictors. Okay, nakaka-apekto talaga siya sa predictors. Okay, so ito ipapakita ko na example ng pag-compute kay Cook's distance. We determine a cutoff. So yung formula ng cutoff, yung number of observations minus yung ilang parameters, okay? Kasama yung yung intercept minus 2. Okay, so i-run ko lang to. So ang cutoff daw guys, 0.869. According to Cook's distance, pag yung Cook's distance is 0.0869, influential yung data point na yan. Pag prinat natin to, okay. Ano sinasabi dito? .08, no? Kanina dito sa cutoff. 0.08. Asan yung 0.08? Banda dito, di ba? 0.08, wala nga lang red line dito. No? 0.08 is somewhere here. So possibly influential to si 1927-32. Okay, so I think paulit-ulit ko na sinasabi yan, no? So it tells us that possibly influential tong points. Hindi ko pa na naglagay dito yan, no? Kung influential nga siya o hindi. Okay. Sige, isasingit ko yun na, tapos papadala ko na yung amended na ano. Okay, wala na. Oh, time na talaga. No? Yun ang problema ko eh. Okay, so ang susunod kasi sana guys, yung homoskedasticity, importante to. No? It's important to check this kasi pag heteroskedastic tayo, very inefficient yung model natin and unstable. And it will give us very bizarre predictions pag nagpre-predict tayo. Remember, ang purpose natin ng regression is to understand the variables. And not only that, is to predict it, use it for predictive purposes. So dalawang test guys, NCV at saka BP, si Bruce Pagan test at saka si NCV. Ito yung medyo lumang test, si NCV. Okay, so quickly guys, i-test natin for heteroskedasticity. Ang null hypothesis nito is, lagyan natin dito, Control C. So what's our null hypothesis? Na there is what, guys? Constant variance, no? NCV means non-constant variance. Ang null hypothesis natin is, guys, pwede makahingi ng 2 minutes?
Yes po, sir.
Okay, thank you. So, kailan guys heteroskedasticity? Yung plot ng error terms natin, hindi siya constant. Ibig sabihin hetero, not constant yung variance. And hindi pa pwede yun kasi assumption ng classical linear regression model. Pag na-violate yan, hindi na uh, hindi na stable or hindi na what's the term for that? Hindi na maaasahan, hindi na dependable yung model natin. Okay, so dito lumalabas sa NCV test na heteroscedastic tayo. But there's another test, guys, si VP test, no? Si Bruce-Pagan test. Tapos dito na tayo sa complete model. Okay, so pakibasa na lang yung explanation dito, guys, kasi magkaiba silang result eh. Tingnan mo dito si Bruce-Pagan. 0.08. So, ano natin? We fail to reject the null hypothesis. So, ibig sabihin nun, homoscedastic yung error terms natin. So, sino masusunod, guys? Si NCV or si Bruce-Pagan test? Okay, so can you read this? Ang answer dyan, guys, ito. Mas reliable tong si BP test. In fact, mas maganda kung ang gagamitin nyo, yung complete na guys, na code, which is this one. Okay, so let's run this, yung complete na code na to. And kasi ito, guys, itong una na to, yung student types is equal to false. Pareho yan sa NCV. Yung modified na BP test is yung student types values is equal to true. So ito yung nakukuha natin. 0.1559 yung p-value. Therefore, homoscedastic yung error terms natin. Kasi we fail to reject. No?
Sir?
Yes?
So, pag higher siya ng 0.05, ibig sabihin homoscedastic siya.
Oo, kasi ang null hypothesis niyan, homoscedastic yung error terms. So we want the p-value to be greater than 0.05 para wag natin i-reject yung null hypothesis, no? Kasi pag less than 0.05 yan, i-reject natin. Oo. Tama. You're correct. Thank you, Bernd, no?
Thank you, sir.
All right. So ito, pakibasa lang, guys, may remedy pag kunyari may heteroscedasticity, mareremedyo na yan. So actually ngayon madali na nga lang kasi may mga heteroscedastic corrected models. So mas madali na ngayon. Okay? Okay. Guys, it's already time. So sana pakibasa to, guys, ito naman, yung 1.4 naman alam na natin yan no? It's testing for multicollinearity. Diba? Na ano natin yan using VIF. So tinignan natin, guys, tinest natin for multicollinearity. Talagang hindi pa pwede kasi 12 no? Dapat nga 5. Pag 5 to 10 medyo shaky na, lalo pa greater than 10. So how can that be remedied? Isa, guys, delete natin yung isa. No? So for purposes of discussion, ito, pakiisundan nyo na lang to. Kunyari, tinanggal natin si log cap. Ang regressor na lang natin si log lab. No? So pakisundan na lang yan. Tapos kinompare natin si model 1 and model 2. Okay, lumalabas nga, guys, na sino mas maganda. Lumalabas talaga mas maganda si model number 2, yung restricted, yung binawasan. Okay, so sa 1 point, I think this is 1.5. 1.5. Testing for linearity, madali lang yan. And lastly, yung normality. Okay? So pakibasa na lang yan, guys. Okay, kung may questions kayo, i-chat niyo lang ako. Okay? Hanggang dyan lang naman, no? And pakibasa to, guys, kasi minsan kung na-violate yung normality, yan ang kaya hinuli ko siya kasi yan pinaka hindi importante sa atin. Maraming mga literature na nagsasabi kung may normality problem yung residuals, for as long as malaki yung data nyo, the central limit theorem will take over. Ibig sabihin, okay lang na kahit na hindi normal yung residuals. All right, guys? Okay, no questions? Okay, thank you very much, guys. Hindi pala. So ngayon na nabigay ko na to, pwede na yung take home natin. Kasi hinintay ko lang to, guys, para may idea na kayo dun sa test. Kasi unfair naman na yung take home test natin, hindi ko pa na-discuss to. Okay? Alright, so sige, guys, maraming salamat. Sorry for the extension.
Okay, so thank you, sir.
Thank you everyone.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Sir,
Salamat.
kailan deadline ng take-home na test?
Yung isa, kasi maiksi lang yun, Saturday. Yung
Sir,
isa mas...
Yun na po yung
Hindi.
test.
Mamaya ko ipopost. Kasi isasabay ko dun sa kabilang section.
Okay po. Thank you, sir.
Okay. Thank you guys.
Thank you, sir.
Salamat. Okay.